So now we're going to move on to class target. Okay. So far we discussed performance measures for interval target. So when you have interval target, you can have the fit statistic, predictive statistics, and then the ranking, which is lift charts, cumulative lift chart, gain chart, decile-wise lift charts. Okay. Now we can do exactly the same thing with classification case as well. Okay. But there are some more nuances for classification problems. So let's look at some of the concepts here. Okay, so judging classifier performance. Okay. Classifier performance is when your target is not an interval target, but a class target. Usually a binary target, which means 0 or 1. So there are going to be only two possible values for the target. If you have more than two, then there are ways to handling that, but most cases it's going to be only two values. So for binary target, actual values of y is either 0 or 1, right? So predicted value then, but if it is not 0 or 1, you can always convert it to 0 or 1. If it is yes and no, then you code one of them as 0 and the other one as 1, right? So there are only two possible values, okay, and they can be numerical. If they are already not numerical, you can always code them as numerical values of 0 and 1. And when we run a model through, try to predict, what we're going to have is the predicted value of y is going to be a number between 0 and 1. Okay? And that number represents the probability that this observation is equal to 1. Okay? So you'll have a value for y hat that can be used as a probability. And then you can set a probability cutoff point and say, all right, if that probability is greater than or equal to 50%, 0.5, then we will classify, okay, our classification is going to be 1. If it is less than 0.5, then the classification is going to be 0. So that's one way of using it. So this probability that we come up with, okay, when we run the model through, and we come up with this y hat, which is a number between 0 and 1, and that represents the probability that the class is equal to 1, and we call that propensity. Propensity is nothing but probability of a particular observation, okay, belonging to the class of interest. So once you have a value for y hat, then you can compute the error like what we did previously, and then compute all the fit statistic that we did previously. Okay, all of that is possible. Okay, but usually that's not something we do. But what we do is the first step in most classification algorithm is to find the propensity and use these probabilities for classification. So we can use these probabilities in two different ways. Okay, one is to generate predicted class membership, which is what I described just now. Okay, you can set a cutoff point. Okay, it need not be 0.5. You can set a high cutoff point. I need the probability to be 0.7. Then only I will say, okay, this is. If you want a lot of confidence in the prediction of success, then you can set a higher probability cutoff point. But if you want to catch all possible successes, then you can set a lower cutoff point. Instead of 0.5, you can say 0.3 or 0.4 or whatever. Okay? So you set a cutoff point and do the prediction. So that's one way of using the propensity. See, another way is to rank order, like what we did in the interval case. Okay, suppose you want to look for the most promising candidates for something. So you have a bunch of candidates, okay, 1,000 candidates, and you want to filter out the most promising ones. So you realize, then you're now rank ordering. So you rank order the cases by propensity. Okay, in descending order, the largest propensity at the top and the least propensity at the bottom. So you have the top case up at the top, and you can use those as our most promising candidates. Okay, So these are the two different ways in which propensity can be used. Okay, so that's your classification. All right. So now we will look at the lift charts. When you're interested in rank ordering, we have lift chart, right? So we'll look at that in a little bit. But right now, let's look at classification. So now, based on the propensities and a cutoff point, you have classified all your observations, okay? So in the case of binary target, there are only two possible classes, right? So you have the actual class, okay, let's call them C sub 1 and C sub 2. So two classes, right? Now, based on the propensities on the cutoff point, you're going to have a predicted class. So you're going to predict a particular observation is as either C1 or C2, right? Now, if the actual class is C1 and your predicted class is also C1, so that means you have predicted correctly, okay? Classified correctly as C1. C1s are predicted as C1. In this case, class is C2 and you have predicted as C1. This is false positive. Okay, so that is a misclassification. All right? So this is the misclassification. Okay? Now here we have class C2, actual class C2, predicted C2. So this is correct. So here we have false negative. The class is positive. Okay, I'm assuming C1 is the positive class, C2 is the negative class, right? It's a positive class being predicted as negative, so false negative. So this is a misclassification as well. So we can compute, okay, so the total cases is add them all up, so you have n cases. So you can now compute, okay, so here is the example that we're going to work on. So we have the actual class, and here are the propensities, okay? We don't know where we got it from, but we have it, okay? So based on 0.5 as our cutoff point, so if cutoff point is 0.5, 13 records are classified as 1. If cutoff point is 0.8, then only 1 is classified. But anyway, let's look at 0.5. When we use 0.5 as the cutoff point, then this is what's going to happen. So there are actually 12 and 12, C sub 1 and C sub 2. C sub 1 is owner, I think. And, well, anyway. So these two are correct classifications, and these two are not. So we have what is called error rate. Error rate is sum these two, right, and divide by the overall n. So accuracy rate is sum these two and divide by n. And obviously accuracy rate is going to be 1 minus the error rate, or error rate or misclassification rate. So in our numerical example, so you have 24 cases. So add this way 3 over 24, so that's our error rate. Add this way is 21 over 24, that's our accuracy.